Alright folks, we're gonna kick this thing out. This is the first video. I think it's gonna be 3 parts. It's gonna be part 1, part 2, part 3. The first video in linear equations in 2 variables, and this is we're solving real world applications of linear equations in 2 variables. Okay, so this is part 1 in 2 variables. I believe I will only have part 1, part 2, part 3, because then we can go into something else. I may still come back, like I said, in the future, and we'll solve more problems. But let's do part 1, part 2, and part 3, and then we'll move on to something else. Alright, so real world applications for linear equations in 2 variables. Please, before I start, subscribe to my channel, like and share this video. Leave comments or questions under the video. I will go to go and answer your question as soon as I can. So we are very relentless. We're gonna keep moving on. We'll solve a bunch of problems, and then we'll continue. We'll go to another topic. Continue with another topic. I will look on my schedule, see what is the next topic we'll discuss. So I should be able to finish this probably by tomorrow. Part 1, part 2, part 3. I don't know if I will get all of it today. Who knows? Maybe I will, Anyway, so let's kick it out. Real world applications of linear equations in 2 variables, okay? This is part 1. Let's solve some problems. Alright, here is our first problem here. We'll have I think it's 4 of them, like exactly with the same graph. It says the line graph shows the overall unemployment rate in the U.S. civilian labor force for the years 2019 through 2016. Use the graph to work each problem, okay? The first problem is that one. Our example 1 is the first problem. So right there, between which pairs of consecutive years did the unemployment rate increase? Okay, it's called line graph. Like I said, we're gonna do this in statistics. When we get to statistics, we're gonna learn more how to read these graphs. But if you look at the graph, it's no more than what we remember. We drew a bunch of graphs. Linear equations in 1 variable, linear equations in 2 variables, especially in 2 variables where we have the slope-intercept form, right? And we use rise and run. We draw a lot of graphs, but most of the stuff we drew were straight line, because we've been dealing with linear equations. Okay, linear means they're straight, they're not curved, but this one is curved, you see, but it's okay. We can still read it. You see what it said? Between which pairs of consecutive years did the unemployment rate increase? Look at the graph. If you see the graph, you see that the unemployment rate decrease all the way. You see that's always going down. Okay, it never increased between this place and that place. The only place it increased a little bit, if you look over here, from here to here, it jumped up because it went up, sloped up, and then it started going sloping down. So we'll say, look at that. The year is 209. What is that? Yeah, 2009 and 210. Those are the years that it increased. You see it right there, right? So the segment between 2009 and 210 shows that the unemployment rate increases, okay? It increases a little bit, not much, and then after that it went down. So those 2 pair consecutive years, right? 2009, right? 2009 and 2010. The unemployment rate increases, okay? It increases. Okay, it increases there. That's all they need to know, man. So you may have something, depending on the exam you're doing, you may have something like this. I think my pen is too thick. Let me reduce it a little bit. You may have something like that, okay? So we're done with this one. We'll move on. We're going to see similar thing next example, but we'll see what they want. The same graph. Say the line graph shows the overall employment rate in the U.S. civilian labor force for the year 2009 through 2016. Use the graph to work each problem. The problem here is, what was the general trend in the unemployment rate between 2010 and 2016? When they mean labor force, labor force is people that are working, not people that are, people that are working. But then it says the overall unemployment rate in the, labor force is, labor force is people that are working, but people that are working in the United States, they want to know people that are not employed. That's called the unemployment rate. Okay, so it said between 2010 2016, what was the general trend in unemployment? Okay, so look at those segments. You say 2010 right here and 2016 right there. Okay, what is the trend? So look at the graph, man. Go from here up. With all the graph we did, man, you should be able to see this stuff. And go over here. Look at that. You see, it went down. It consistently went down. It sloped down, even though it's curved. You see it, right? So we're gonna say between 2010 and 2016, right? The unemployment rate was always decreasing. Always decreasing, okay? See, so unemployment was always, there was no place you increased. Always decreasing in that period. The period asked, which is between 2010 and 2016, okay? Alright, so let's move on to the next one. These are easy problems, but I just want to give you a flavor, the kind of question you may see. And these are things to know. If you read newspapers or online news agency, they will talk about stuff like this. You need to understand how to read the graph. That's how you read it. Okay? So let's go to example 3. It's going to be the same thing, but a different question. So they're giving us the same graph. He said the question is here. Estimate the overall unemployment rate in 2011 and 2012. Alright? About how much did the unemployment rate decline between 2011 and 2012? See, they concentrate on those 2 years, okay? 2011 and 20, right here, 2011 and 2012. So they want you to concentrate. You see right here, 2011. By the way, this is unemployment rate. This is year here. That's how you draw this kind of graph. You remember when we draw a graph, we say X and Y. So X and Y, X axis and Y axis can be anything. So depending, because this is an applied area of using the Cartesian coordinate. So it's applied. Of course, they have to put the information. The information on the y-axis represent years. The information on the x-axis the information on the x-axis represent years. The information on the y-axis represent the rate of unemployment, okay? So between 2011 and 2012, see, it went down. It didn't increase. It went down, but they want to know how much. They say estimate it. And how much did it decline? Well, if you estimate it, right, look, see, you use the blocks. See the blocks here, the rays are here, like I said, the rays are this axis here. Use the blocks from here to here. Each block is, from here to here is 4. From here to here, 5. That means 1. Each block is 1. Let me see, 5, 6, 7, 8, 9. So each block is a space of 1. From here to here is 1. So you see, if you look at between 2011 and basically it went down 1% or 1 block. You see that, right? It went down 1 block, you see? So we can say that, I mean, what is they say? Estimated overall employment rate, because these are rates. Okay, these are rates. So you can say here, 2011 it was, you can read it up here, it was 9. It was 9%, you know. The rates are in percent, you see. It says here, rates are in percent. And then over here, look at that, go over here, it's 8. Over here it's 9. Okay, over there was 8% on 2012. 2011 it was 9%. If you subtract them, then you get the estimate. If you subtract them, you get 1%. That's how you read this. That's how I read it. You know, you subtract, you get 1%. Okay. All right. So that's all they need, man. Say about how much did the unemployment rate decline? So it declined because you see it's going down. It declined about what is 1%, because it went down. It went from here down to here. You know, so it declined about 1%. That's it. Don't read too much into the problem. Just look at the graph and estimate stuff from the graph. Okay. So let's move on to the next one. Let's move on to the next one. We're done with that one. Okay, look at this one. It says, the same graph, it says, during which year, I'm reading here, during which year was the unemployment rate greater than 9%, but less than 10%? Okay, well, you know what you're talking about, you know, because it decreased, in other words, that year they're talking about, it decreased, it was between 9% and 10%. And then second question, was the unemployment rate less than 7? Okay. So they're talking about 9% right here. Okay. Was the unemployment rate greater than 9%? Let me see. Yeah, of course, because it went up. It went up during which year? Remember, don't forget that part. During which year? And then it went up over here. Was unemployment rate greater than 9% but less than? Yes, of course it was. It went from 9 to almost, it wasn't quite 10. It's less than 10, because 10 is over here. See, 10 is over here because it's like that. So it's less than 10, right? But greater than 9, yes. You see it, right? And that year is 2010. You see it? That year is 2010. So for A, the year is 2010. 2010, okay? That's for A. Because between the from 2019 it went up to 2010, and then after that it started decreasing. You see it right there, right? Okay. B, what does he say in B? Was the unemployment rate less than 7%? I think so. Well, not that I think so, it is. It is. So it was below, yes, below, was the unemployment rate less than 3? Because if you look at, well, less than 7, sorry. Is it less than 7%? Yes. Hang on a minute. Hang on. Was it less than 7? The unemployment that no, it's actually not, 7 is over here. It wasn't less than 7%. It was more. So no, the answer is no, because the unemployment rate in that particular year is about 9.5. It was about 9.5%. So the question was, the unemployment less than 7? Is said no. It wasn't less than 7, because 7 is over here. 7% is over here. Okay, it's talking about that particular year right there. That year is 2010. See? All right, you get that, right? So, because you see, if he, what is that? What's that? Because you see, when it's less than 7%, it's over here. If you go over here, right? Then it is less than 7% here, less than 7% here, less than 7% here, but above that is greater here, greater here, greater here. We're talking about 2010 is greater than 7%. Because they're talking about during which years, right? So over here is less, less, less. All right, but over here greater than 7%. Okay, so the question is kind of a little bit confusing, man. Because you assume they're talking about 2010 based on this one here. During which year was the unemployment rate greater than, okay, was unemployment rate less than, see? Or maybe say during which years was unemployment okay, I misread the question. If that's what they mean, during which years was unemployment less than 7, then it's here 2014. So I think I misread. It's 2014, 2015, and 2016. Those are the years the unemployment rate was forget about this thing here. Those are the years it was less than 7%. Because you see 7% is over here, sorry. 7% is over here, man. On the graph. So the years below it, see that 2013 is not included because 2013 is over here, above 7%. So the ones that are below 7% are 2014, 2015, and 2016. Sorry, I think I misread that question. But that's what is going on there, okay? So we continue from there. Alright, folks, I'm supposed to mention something. Okay. I cannot mention it, but I want to make it clear. All the 4 problems we'll solve using this graph, they involve linear equations in 2 variables, right? Because there is here, there is here is 1 variable, which is x-axis. There is y, that is called rate in percentage, which is another variable. So there are 2 variables, rate and year. Those are 2 variables because you see we are looking for, the rate, how the unemployment rate decreased over here. So you go and see the year it decreased, and then the corresponding rate. See the corresponding rate from that year. So we're dealing with 2 variables. Make sure that you understand that, okay? So let's move on to the next problem. All right, this is the next problem. So when you get to the next problem, you will see that the idea that we're working with 2 variables will be very clear. Let's read that. It says, suppose that it costs $5,000 to start up a business selling snow cones. Okay, it's a business startup that sells snow cones. Furthermore, it costs 50 cents to make 1 cone per cone in labor, ice, syrup, and overhead. Okay, so the cost of producing 1 cone ready to go is 50 cents. Then it says the cost y in dollars to make X snow cones is given by the linear equation. You see right here, this equation here. All right. So the cost y in dollars to make X snow cone is given by that. See, this is the startup cost. This is the cost per cone, and the X is there and the Y is there. So it's linear equation in 2 variables. Okay. It says express each of the following as an ordered pair. When 100 snow cones are made, the cost is $5,050. So let's do number A, then we'll go to number B. Okay. So here is what's going on. You gotta understand what is going on. The cost Y. Y is the cost in dollar, okay? X is the number of snow cones made, okay? And this equation represent those 2 variables in a linear equation in 2 variables, okay? And then basically what they say, when 100 snow cones are made and the cost is this, expressed as an ordered pair. What they say basically solve that. They say solve y equals to 0.550x or 5x plus 5,000, okay? When solve that, because this is snow cone, which is x, when x is equals to 1,000 and y, which is the cost, is equals to 5,050. That's all they're saying there. They're telling you take this value of x and substitute it into this equation. That's what they're saying. Then you get an ordered pair. When you solve it, you're gonna get an ordered pair, okay? You see that, right? I think they want you to substitute one after another. You substitute this first, you get the value of y. Then you substitute this secondly, you get the value of x. You see that, right? So let's say x is equals to 100. You substitute that, what do you get? You get 0.50 times 100 plus 500. You see what I'm doing, right? See it? Okay, so what is 50.50 times 100? What is that? You gotta be able to figure that out, okay? 0.5, right? 0.5 times 100. We can express that in a fraction, okay? But if you multiply that, you get 50 plus 500. 5,000. Okay. I'm sorry. I want to make this clear. Sorry about that. It's x is equals to 100, and then y is equals to that. So you keep solving. Y is equals to that. Y is equals to that. That will be 5,050. See that? So that's the value of y. Now we'll get the value of x. They say, suppose they say you're given, suppose y is equals to 50. Oh Lord, what the hell? You see that? If y is 50, what is x? Well, we'll put it in there. We're gonna get x equals to 100. That's what it seems. Well, I take it back. Let's see. I think we should. So y is equals to 50, because we just got y equal to 50 there. If y is equal to 50, we're gonna get, I don't know what kind of problem is this, if you put that in there, you if you put that in there, you get y, let me see, sorry. If you put that value of y, you get, what are you gonna get? You get 50 is equals to, maybe I'm overthinking it. Maybe I'm overthinking it. I think we're just supposed to express it instead of solving anything. But it's okay. We can solve anyway. Let me see. 50 is equals to, what is that? Right there. 50 is equals to 0.5 50x plus 500, okay? 5,000. So you solve for x. That x should be 100, but it's okay. Since I already started solving it, let's solve it. So what you're gonna do is you say 50 minus 5,000, okay, is equals to 0.50x. You simplify that, what do you get? You get 50, okay? It's equals to 0.50x. X is equals to, just take 50 divided by 0.5, okay? And you should get 100. That's what you should get. I think I overthought the problem. I did overthink the problem, man. I'll tell you why. So I'm thinking now while I'm solving it, I overthought it. Because what they're saying, express this and that. as an ordered pair. But it's okay, we'll solve it. So as an ordered pair, those two things will be, oh Lord, just give me a minute. As an ordered pair, those two things will be like this. 100 is, x is 100. So right here, put x first. And then y second, which is 50, 50. Okay, that's an ordered pair. That's what they want. I mean, we already have the values of x. I don't even know why we have to solve anything. But yeah, you learn something from there, because if you have any value you have that satisfies the equation, will make the equation true. We just prove that no matter if you put the value of y there and put the value of x there, the equation will be true. That's what we just showed. So, we gave you an additional bonus. We have to look at the problem. Now, let's say when the cost is 6,000, the number of snow cone made. See, we don't need to solve anything. We need to express, we can do the same thing we did above. We're going to come up with the same thing. So, B, the ordered pair is, let me see, what does it say? X is, because this is X value and this is Y value, okay? 2,000. X is 2,000 and Y is what? Y is 6,000. That's all they want. So that's all they want. We don't need to do or start solving anything. So this is X here and this is Y here. Okay? So we'll move on to the next problem, man. We're done with that one. I overthought it. But anyway, here's the new problem. It says, oh Lord, it's a lot of stuff to do. And okay, so it says the table shows the worldwide number of monthly active Facebook users at year end in millions. Okay, at year end in number of worldwide Facebook users. Okay, towards the end of the year. Okay. So the end of that year of 2010, the users were 608 million, because remember it's in million. Okay, so that's how you read the rest of it. All right, so let's see what they want. You say write the data from the table as ordered pair. Write the data from the table as ordered pairs, where X represent the year, Y represent the number of Facebook users. Okay. Y X represent. So I know what. It's the same thing we did above. They want you to write that as an ordered pair, man. That's A. Oh Lord. So A wants you to write X represent year, Y represent number of users in millions. Okay. You don't have to write the whole million, but you will know it's in million. So for 2010 it will be 2010. The other pair is and then 608. That's all they want, man. See, they want you to translate this into other pair, because see, year represent. That's what it says here. Year represent X, Y represent number of users in millions. Okay. So what they want is this. 2011 the users is 845 million, and then 2012 the users is 1056. Okay, hang on, I'm making a mess. Users is 1056. 1056 million, okay? And then 2013, you have 2013. That's all they want you to write, so we'll write it. Okay, so that 2014, all right, is 1393. Okay, 2015 is how many users? 1591. And then 2016 is 1860. Okay, so you got that. That's A. And then B, what does the other pair 2016 1860 mean in the context of this problem? Okay. Okay, so it's okay. They want you to interpret what does that mean. B. 20, that's this other page, 2016, where is it? 20, right here. 20, that's this, that other page, okay, 2016, 1860. That basically means in 2016, right? In 2016, 1860 million, all right, see, that's million users of Facebook. So that means there were, you can make a sentence, there were 1860 million users of Facebook. Okay, that's all that is saying. That's what that means, man. Okay, C. Make a scatter make a scatter diagram of the other pairs of data. Use the given grid. Oh, they want you to use this grid here. This is C here. Use this to solve the problem. It's okay, man. The scatter diagram is we're gonna do that in details when we study statistics. We're gonna have a course in statistics. So this is x-axis right there, okay? This is y-axis. So the two variables. Because this problem has two variables. So 2010 608 right there. This is year here. What is it? Make a scatter diagram of the other pair of data. Okay, these are the stuff we wrote down here, but I can read it from the table. So 2010, how many users? Is 608. 608 on 2010 is okay. 608, 600 is here. 608 probably somewhere here. Okay. Let me clear that because it says scatter diagram. So you don't want to put any extraneous dot. You get one there. That's about 608. 2011, 845. 2011, you gotta be careful. They didn't write it, but it's right here. 2011, okay? Let me clear that out. Because they want a scatter diagram. 2011 is right there. So what is that? It's 845. 845 should be, let me see. Each space between here, okay, I'm sorry. The space between between two numbers is about, how many is there? Let me see, 600, 0 to 600, then another, I think the space is 200 each, because from 600 to 800 is 2. 800 to 1000 is 200. 1000 to 1200 is 200. So, okay. So we got that determined. So we said 2011 is between 2010 and 2012. So there were 845. So it will be, let me see, 845. Should be probably somewhere here. Okay. 2012 has a 1056. 2012 is right there. 1056 should probably be somewhere. Oh man, it's kind of hard, man. 10 probably somewhere here. Okay. 2013 is between 2012 and 2014. 2013 has 1228. So 1228 will probably be somewhere here. Okay. And then 2014 is about 1393. 2014 is about 1393, not quite 14, so it's probably over here, somewhere there. Okay, so 2015 is between 2014 and 16. 2015 is 1590 something. Okay, 50. Actually, so I think I made a mistake. 13, not to. Yeah. Okay, sorry. Okay. 2015 is 1591. 1591 should be, it's close to 1600, so it should be somewhere here. All right. And then 2016 is how many? 1860. 18 is over here, then 1860 should be somewhere here, okay? This is just an estimate. You see, if we draw a line, let me say, I bet you that's what they're going to say. Describe the pattern indicator. It's a straight line, man. So that's what they want for C. Then it says in D, describe the pattern. Let me see. Describe the pattern indicated by the points on the scatter diagram. What happened to the world number of monthly active Facebook? It increased, man. You see? So if the pattern is a straight line and it's increasing, the slope is increasing, right? So it's linear, almost linear. The number is increasing. You know, the number is number of users increasing every year like they jump. Okay, you know, so that's what is going on. You know, every time it jumps, you know, it's jumping. You see, it's linear there, man. You know, so that's what is going on there. You can even see it. You can see it by looking at the. Yeah, you can look at it by looking at the numbers. If over here is, they say is, what is they say? They say it's 2010 is 608. And then 2016 is, look at that, it's jumped to 1860. So, but the line will tell you the same story. So let's leave that problem alone. We're done with it. You know, I hope you get the message, you get the point they're trying to make there. You know, they show you that Facebook users are increasing over the years. That's all. Okay, I think it's similar problem. So let's. All right, this problem is similar to the one we solved before. So let's knock it out. You said the table shows the number of U.S. students who studied abroad in thousands. Okay. Okay, Facebook thing was in million. This one is in thousands. You see, the number of students who studied abroad. So they give you different years. Then he said, write the data from the table as ordered pairs, X and Y, where X represents the year, Y represents the number of students in thousands studying abroad. Okay, so number A, question number A is easy. You just write the ordered pairs. X represents the year. You always gotta get that right. See, that's what they did here. X represents the year. See the year here, and Y represent number of students right there. Number of students, okay? So the ordered pair they're talking about is 209, then the number of students that year is 270. Basically, that's all you're gonna do, pair all of them together like that. 2010 and 274, okay. 2011 and 283. I think it's see, steadily increasing. 2012 is 289. Okay. All right. 20. What is that? 2013 is 304. It's steadily increasing, man. Okay. 2014 is 313. See, steadily increasing, man. 15, sorry, is at 325. So if you look at the number on the number of students, it's steadily increasing. And then you say, what does the other pair? 2015 and 325, that's this one. What does that mean in the context of this problem? See, these are questions that help you to understand what is going on. Because this is a linear equation in two variables, x and y. And x represents year, y represents number of students. So that question B means Or that other pair means, it means in 2015 there were 325 students, American students, right? American students who studied abroad. That's all. That's all that means, man. So that's all that means. Okay. I mean, it just helps you to understand what is going on. This is it helps you to understand this is not an abstraction. Well, they try to make it abstract, man, by putting all this stuff in abstract form, but the numbers mean something. That's all it says, man. Okay. So what is C? C says, make a scatter diagram of the other pair of data. Use the given grid. See, that's the grid right there, up there on the right hand side on top. So they say 20 will just translating the data into the graph. That's all. So 2009 there were 270. So this one is easy. See, 2009 270 right there. 2010 has 274. By the way, look at how the scale. See, 260, 270, 280. So there's 10 between the numbers. This from from here, anywhere from here to here is 10 units. Okay, so I gotta clean that. You have to understand that. Okay, so 2010 is between 29 and this. 2010 is between them right there. 2010 has 274, so it will be 270 here, and then 274. 274 is about here. Okay, and then 2011 has 283. 2011 it will be 280 there. 283 is about here. Okay. Alright, this is here. This is about here, and then it said 2012 289. 2012 is 289. It's close to 290. It's probably about here. 2013 is 304. 2013 is 300. This 100 is here. 304 is about here. 20. Actually, yeah, it's okay. 20. What is that? 2014 between 2013 and 2015. 14 is 311. I'm sorry. 313 students. So this is 310 here, 313, so probably somewhere here. 2015 is 325. 2015 is 325. That's 320 is here. 325 is somewhere here. You notice that it's a straight line, man. Okay, describe the pattern indicated by the points of the number. What was the trend in the number of students studying abroad? It's almost a straight line, because my putting the scatter diagram is not always accurate, because the scale is not very good. So it's a straight line, man. You think steadily, number of students that studied abroad is steadily increased. That's all. Okay, the number D. They say, what is that? This is C. They say interpret it. Describe the pattern. Like I said, the trend is that students, as a year number of year, okay, increases. It doesn't matter how you write it. The number of students, okay, the number of students that study abroad increases, okay, increases. Number of students increases. Okay, the line is linear. The line is linear. Okay, that's the pattern. The line is linear. All right, so that's all you gotta say, man. It's approximately linear. It's not quite linear. Maybe I made a mistake. I don't really know. So That's what that is asking you. Let's move on to the next problem. Is it the same thing? No, this is a little different. What does that say? The next problem said the maximum benefit for the heart from exercising occurs when the heart rate is in the target heart rate zone. The lower limit of this zone can be approximated by the linear equation right there, where S represents age, Y represents heartbeats per minute. Okay? It says complete the table of values for this linear equation. Okay. They want you to complete the table of values. Alright? So what does that mean? It's actually not that difficult. I'll show you. Let me put you pause for it. What that is saying is that for a complete table of values. Okay. What is that saying over there is, we'll have age. Because you see, X represents age, Y represents heartbeat. So the table of value gives you a value of X, okay, and it's telling you to find the value of Y. This is the value of Y here. Okay, so basically you substitute the value of. Notice that this is a linear equation in two variables. One variable X is giving you, and they want you to find Y. That's all. That's all that means. So we can do that. Okay, when y is equals to minus 0.65. Okay, 65x plus 143. Okay, and then when x is equals to 20, as given in over here in the table, right? When x is 20, then what is the value of y? That's what they're asking you to do. It's not, we've done that many times in the past, okay? So you say y is equals to minus 0.65, okay, times 20, that's all, plus 143, okay? So you can do that. You multiply that out 0.05 times 20, okay? You get 13, sorry. You get 13, actually minus 13. You get minus 13 plus 143. So you subtract that from 143, okay? What do you get? You get 130, okay? So you put it here, 130. That's what they want you to do. You keep doing that, man. That's what they want you to do. When x is equals to, what is that? X is equals to 40. Alright, what does that mean? Okay, you say y is equals to minus 0.65. Okay, 40 plus 143. See that? Okay, let me do all of them. When x is equal, that's 40. When x is equals to 60, you get that s 60. You get that y is equals to minus 0.65 times 60, okay? Plus 143. That's what they want you to do. The same thing when it's 80. Okay, you do the same thing. X equals to 80. Y is equals to this 65 times 80 plus 143, okay? So you get that, you get all that, you put it on the table. That's all they want you to do. I hope you see it, right? That's why I say you gotta understand what is going on. If you understand what is going on, the rest are easy, see? So, but if you don't understand what is going on, then it looks difficult, but it's not difficult. Okay? 143 minus 143, you get 117, okay? I want to see if there's a pattern now. Well, I think pattern is developing. Alright, 0.65 times 60. Okay, the larger the x value, it decreases. Okay, you see that, right? This is 104. All right. Okay, so if you have 0.65 times 80, okay, and you subtract, subtract that from 143, right? What do you get? You get 90. You get 91. Okay. Okay, so it's decreasing. So what you get here is 40 is what? 40 is 117. 60 is 104. Okay, and then 80 is 91. You see? All right. See, the less the age, the younger the person is, the heartbeat goes up. The older it goes down. So that's all that thing is saying there, man. I bet you that's what they're gonna ask. What did they say? Write the data from the table of value as ordered pair. Okay, they want us to write it as ordered pair. That's fine. We can do that. That's no big deal. What is that? It's no big deal, see. So we can write that as an ordered pair. What they want for B, write that as an ordered pair. What they want for B is this. They want you to write the table as an ordered pair. We got it here. So we got it here, we got it here, we got it here, we got it here. Here, and the first one is what? X is 20. So it's 20, what is that? 130. The second one is X is 40. And then what is that? 117. The third one is X is 60. Then 104. The last one is X 80, then 91. You see that? Those are the order pair for B. Then you say, what is that? See, make a scatter diagram of the data. Do the points lie in a linear pattern? So they want us to make scatter diagram, man. Okay, so actually we'll be easier now because we choose our own. We choose our own interval. Okay, so don't forget what they do. You have X and Y. So when you draw that like that, this is a D, okay? When you draw that, you gotta go like that. And then you gotta go like that. You see it, right? This is Y and this is X. Okay? Alright, so X is the first value, okay? Y is the second value, okay? So notice that since we're in the positive direction, there's no negative number there. You know what? Let's take advantage of that. Let me clean this. We take advantage of that. We give us enough space. So we'll put it here. We'll put X here. And then give us space with Y. We got more space. Okay. But first you gotta choose the unit. Okay, it's kind of, I wish we have a graphing something, but we can graph it with the hand. It's not that difficult. So what you do, you choose the unit because Y is up to 130. So 1, 2, 3. Sorry. 1, 2, 3, 4, 5. So we can say, yeah, we don't really have enough, so we have to squeeze it in. We can say, let's do X first. X, the highest X is 80. So we said this is 10, this is 20. We're not gonna have enough space, so we'll crunch it a little bit, but crunch it. This is all right. This is 30. You know what? Let's be smart. Let's do this 30. So it gives us that, and then we'll do 1, 2, 3. This is 60. 1, 2, 3. Okay. Let's make it a little longer. This is x. So 1, 2, 3, 30 right here. 1, 2, 3, 60. 1, 2, 3, 90. So 80 is somewhere. 80 is somewhere here. This is 90 and this is 80, okay? Alright. So, but you see, y gonna give us problem because y has the values are high. So it's bound to give us some problem. Yeah, I wish we had more space. We can make it longer. It's okay, man. We'll crunch it together like that. So we'll go down like that. Man, we gotta go up to 130. 1, 2, 3, 4. Let's say this is 50. I don't know if we'll have enough, but small unit is each of them is 1, 2, 3, 4, 5. Each of them is 10. And then here we get 100, okay? And then here we get 150. So 130 is where? 100 and 30 is here. Okay. You see that, right? Alright, we'll draw the first one, 20 and 130. Let me see, 1, 2, 3. 20 is here. And then 130. 130 would be here. So that's the scatter diagram right here. Okay? And then 40 and 117. 40 is here. Okay? Let me see, 20, 40, 50. Yeah. Okay, so then what is that in 117? This is 100 here. Okay, so each unit, that thing is each 1, 2, 3, 4, 5. Each is about 10. So 117 will be around somewhere here. Yeah, no, maybe quite 117. See, over here is 120, okay, so 117 should be here. We'll put 117 there. So this thing is not an exact science. Oh, I'm sorry, 117, I'm sorry, I messed up, man. Yeah, I'm getting tired already. Clear that. We're gonna put it by with what is that? 40, right? 40 is over here. So 117 is over here. 120, 117 is over here. This is 40 here. Okay. And then 60 and 104. 60 is here. Where is 104? 100 is 100 is here. 104 should be, because 1 is 104 should be somewhere here. 104 somewhere there. Let's clean this one here. Okay. And then what is that? 60 and 104. We did that. 80 and 91. So 80, 91 should be, this is 50 here. 50 is here. And then you have 1, 2, 3, 60, 70, 80, 91 is somewhere here. So we clean the ones we don't need. So basically, see, it's the straight line, man. So we'll manage to do that with hand. So what does that say? What is the next equation? I mean, what is the next question? Make a scattering or do the points lie in linear form? Yes, it does. Yes, it does, because if you can put the line like there. Yeah. See, we might not be exactly accurate, but it looks like, I would say yes. Yeah. Yes, in linear form, okay. I would say yes. Alright. So you see, when you're doing graph by hand, if you have a graph paper, if you have more space, you can make easier on yourself. Make the unit, the distance between things, you make it larger. If you make it larger, then it will be easier for you to draw stuff, okay? But we don't really have a bunch of space to work with, so we're trying to get this stuff done. Alright, so we'll move on to the next problem. What is the next problem? That way we can knock out a couple of this stuff here. The next problem says maximum benefit for the heart from exercising occurs when the heart rate is in the target heart rate zone. The upper limit of this zone can be approximated by the linear equation right there, where X represents age, Y represents heartbeat per minute. Okay, notice that equation is a linear equation in two variables, okay? I think it's the same thing we did above. They want us to A, complete the table of value, B, write the data from the table of value as ordered per, C, make a scatter diagram. It's the same thing we did above, man. So it's the same thing. Complete the table of value. So basically you say Y, sorry, you don't want to write in pen, in red. Y is equals to, what is that? Minus 0.85x plus 187, okay? And they give you points there. 20, when x is equals to 20, what do you get? Y is equals to minus 0.85 times 20, okay? 20 plus 187. That's all. So we'll keep going. When x is equals to 40, y is equals to minus 0.85 times 40, okay? Plus 187. Okay, when x is equals to 60, y is equals to minus 0.85 times 60, okay? Plus 187, okay? That's what is given, okay? When x equals to 80, y is equals to, right there, times 80. Okay, so we're gonna get, do all this, and then we use it to find the other pair, okay? We're gonna do all that. So that's all they want, the number A. Okay, here I went ahead and calculated all that stuff, okay? So then, what is it? Complete the value for this linear, complete the table. Okay, so you get 170, you get 153, you get 136, and you get 119, okay? That's what they want. Write the data from the table of value as all that pair. That's all. See, this is A and this is B here. You're writing that as all that pair. Okay, so it's 2170. 40. The X value is first. 40, 153, 130. I'm sorry. You gotta put value of X first. Okay, 60, 136, okay? And then 80, and what is that? 119. That's it. We write it as other pairs. Make a scatter diagram of the data. Describe the pattern. Okay. It's the same thing we did before. They want us to make a scatter diagram. You see, the numbers, let me see. The Y values are long. The X values are kind of easy to handle. So let's use up all this space. I try to approximate the values, right? You see them there? In the X axis, 120 is here, 140 is here, 160 is here, 180 is here, okay? And then here is 119, 136, 153, 170, okay? So then we'll enter the data. 20 and 170 is over here. This is 20 right there, so you go up. Basically, you go up to 20 and what? 20 and 170 should be somewhere here. 20 and 170 should be here, okay? We go all the way down. You trace it, it's right here. Okay, and then we'll have, what is the other one? 40 and 153. So you got 40 here, you trace it up. I want to trace it up, that way you don't put it in the wrong place. You can do it anywhere you want it, because I can't see the whole thing. 20 and 153, where is 153? Let's trace it up right here. That's 153 somewhere here. 153 is somewhere here, okay? Alright, what is the other one? 60 and 136. Okay, we know 60 is there, we can see it. 60 and 136. Where is 136? Right here. 136 is somewhere here. Okay, see, we can see that. Okay, we can see that clearly. So 80 and 119. Where is 80? So we gotta trace it up. 80 and 119. That's 80. We'll trace it up here. Where is 119? 119 is somewhere here. Oh, sorry. 119 is here somewhere. Okay, you see? You see, the thing traced a linear. It's kind of straight. You see that maybe we made a little mistake. So it's a linear. The thing is linear, man. So what we can say, what they ask us, make a scatter diagram that describe the pattern. It's linear, man. It's almost linear. So we say it's linear. This stuff is acting up. It's linear, okay? Alright, so we're done with that, man. I took my time to draw the perfect diagram, okay? So we're done with that. Alright, folks, here's example 10, okay? Let's read that. It says the weight, Y in pounds, of a man taller than 60 inch can be approximated by the linear equation. Y equals to 5.5x minus 220, where x is the height of the man in inches. Use the equation to approximate the weight of men whose heights are 62 inches, 66 inches, and 77 inches. Use the equation. Okay. Write the information about part A as 3 ordered pairs. Grab the equation for x greater than 62 using the data from part B. Use the graph to estimate the height of a man whose weight is 155 pounds. Then use the equation to find the height of this man to the nearest inch. You see, that's a lot, but we can do it. This is the equation given is a linear equation in 2 variables, so it's nothing magic about that. We tackled it before, so let's tackle this thing here. Okay, so we just go systematically, okay, see what they want. Based on what they want, will solve the problem. It's no big deal. Alright, notice something. You are given the equation, said, the equation represents a man, a man taller than 60 inch, okay, right there. Okay, so don't get confused. Then it says use the equation to find men whose height are 62, 66, 76. They are taller than 60, okay? This man is 60, but the equation represents men who are taller than 60, okay? So there's nothing fantastic about that. We'll just read it carefully, understand what they're saying, and then we'll move on, you see. So what they're saying there is in A, they're saying that y is equals to 5.5x minus 220, okay? I'm sorry, 220 minus 220. Okay, that's the height. The weight, no, that's the weight of the man. They say use the equation to approximate the weight of men who are. So y is the weight to approximate the weight of, and h is height. Okay, h is height. Yeah, see, h is height right there. We don't need to write it anything. Okay, so basically what he's saying is, basically what he's saying there is, when you given that equation, said evaluate the equation when x is equals to 62, when x is equals to 66, and when x is equals to, what is that, 72. That's what that part A is saying. You evaluate that equation. So when x is equals to 62, what do we got? We got y is equals to 5 times 5, because x is the height. I mean, the x is the what? X is given. X is the height. Yes, is given 62 minus 220. That's all. So you simplify that. What is that? That's all that thing is asking you to do, man. It's asking you to put the value of y and solve for, put the value of x and solve for y. That's all. Okay, if you do that, you have 5.5 times 62. Okay, you get 341 minus 220. What is that? Minus 220, you get 121. Okay, that's what you get there. And then this one, y is equals to 5.5 times 66. That's all. Minus 220. What is that? Okay, that's what it's asking you to do, man. 66 times 5.5, you get 363 minus 220. What do you get? That's what that is asking you to do. 143. Okay, and over here is y is equals to 5.5 times 72 minus 220. What is that? You keep moving on slowly and methodologically done. Don't be distracted. Just move on, focus, and you get it. Alright, so 5.5 times 72, you get 396. Okay, minus 220. What do you get? You get 176. So that's all it's asking us to do there. We did that. It said B, write the information from part A as 3 ordered pairs. So that's B. Section B say write that as 3 ordered pairs. What they're saying is you got the value of x and you got the value of y. So what you said, the order pairs are 62. You got the value of y right here, 121. Okay, so if you got 66, the value of y is what? 143. Okay, if x is 72, what is the value of y? Is 176. That's what that is saying. So we're done with B. And then see, grab the equation for x greater than 62 using data from part A. For equation, where are they bringing? We haven't done absolute value, but it's okay. I think they covered it somewhere. Grab the equation for x greater than 62. What are they saying there? X this is x greater than or equal to 62. So those 3 values, the 3 values we use. This is 62. X equals to greater or equal to 62. That was included. That's included. That's included. Okay, so for the data in B, let me see. For data in B, grab the equation. Okay, so we're gonna grab the equation. Use the graph to estimate the height of man. Okay, So we have to grab the equation carefully. That way we can use it to answer question number D. Remember I talked about this where you can extrapolate. If you're given information, if you're given a graph, you can extrapolate what is not, the points that are not giving you. So look at the points, man. We want to have a good clean graph. Okay, 62, 66, 72, 121. So we'll have to, you know what, let me go down here and use them. Oh man, I already have a problem written there. You know what? It's okay. We'll do it. We'll do it here. Let's do it here. It's okay. What can I do? We'll go ahead and do it here. We'll do it like that. See, I got this problem written down already. And then we'll, let's take it down here. Take it all the way down here because we're going to be using the first quadrant. So the second, third, and the first quadrant are not really important. This is Y and this is X. Okay. So the highest X will have is 72. The lowest 62. So 1, 2, 3, 4, 5. So if we say 30, 90, and then we can go further. Let's clear that. We can go all the way to the right. Let's put X here. So if we say 30, 60, 90, and 120. Yeah, no. Yeah, that would be good. Yes, that's for X. So we'll say 30, 60, 90, right? The highest we'll have is 72. Yeah, that's good for, that thing is actually good for X, okay? And then Y the highest we'll have is 176. So you gotta make sure that you choose the unit, that way you don't have problem when you're drawing it. The highest we'll have is 176. 1, 2, 3, 4, 5. Let's say this is, if that's 30, this is 60, 70, I'm sorry, 30, 60, 90, 120, and 100, and 100, and what is that? 150. So we need more space. Okay. Yeah, it's kind of crazy, man. Let me see. 150, and then if we get one more, 108. You know what? I'm gonna stretch this right there. Sorry, I'm gonna go like that. So that's what we gotta do because we don't have space. This is 0, 30, 60, 90. Okay. Add 30 to it is 120, and over here is, let me remove that little Y, that way somebody will remove that. So 120, then 150 over here, okay? 150 over here, and then the next one we'll go ahead and use this. This is at 30, that's 180, okay? Yeah, so that will cover us. It's okay. It will cover us. So let's use a red ink to draw this. What is the first one? 62. X equals to 62. Y equals to 121. So each point here, 1, 2, 3, 4, 5. Each point is 6. T divided by 5. Yeah, it's 6. So how do we get that? It's 62 is 62 is somewhere here. 62, we got a red mark. 62 probably start here, and then 62 lands in 121. Where is 121? Again, this side each is 6, so we're trying to find 121. Here is 120. So we're gonna go, let me see. I draw the line because I want to see where I land. I don't want to land in the wrong place. The line is not necessary. 121 should be somewhere here. That's enough. That's enough for us. And then 66 is, yeah, I think that one is 6. Each side is 6. So each side is 6. Each unit is 6. So what we're looking for 66. 66 is here. This is 66. Okay, I think I was able to trace everything. You see? So this is 160. What is that last one? It's 72 is here. And it goes to 76. 76 is right here, okay? So you draw the line. Put a ruler, we just have to approximate. We'll put a ruler here. We'll go there like that. You keep going, okay? It can come down much. It's a line with a negative slope, okay? You remember we talked about that? Alright. So we were able to draw that then. So where is that? What does it say? It says, use the graph to estimate the height of a man who weighs 155 pounds. Remember that X is height, Y is weight. This is weight. Okay, Y is weight. And then this is X is height, okay? Remember that, okay? Okay. So if a man is 155, right? So this is 150. Each unit is 6. So it should be here somewhere, not quite 156, but 155. So then what you do, you take that, see where it meets the graph, right there. It meets the graph somewhere there. If our graph is correct, and then you trace it down, you trace that thing down to right here, okay? So let me use a black ink. You trace it from here, from 150, weight to 155, right? Weight to 155. What is the height? You go down there to the x-axis to get the height. That's all that is saying. I talked about this in the past. Notice it's between 66 and 72. So 66 is right here, and from here to here is like 6. That's why I had to write it down. That way I remember. Okay, so 66 is there. It's almost at the half, a little bit greater than half. I would say that place is about 66 plus a little over 3, maybe 3 point something. So that would be about 69. What we're looking about, this is probably about 69 right there. 69 is the 60. What is that? 69 inch? No, yeah, 69 inches about the height. I don't know if we'll probably a lot off or something. I don't know. Let me see the number we did. We did number 10. Okay. So we'll probably a little off. I don't know, man. So that's what I got. So if we're off because our graph is off. So the man is that height right there, 69. If we were off we can solve it, but we can solve it, mathematically, but they say use the graph. So I think that's all I have for that one, man. We'll move on. We're gonna move on to something else. We'll leave it there. Okay, here is the next problem. I'm gonna read it. That way we can tackle it. All right. It says that. It says that the height, right, in centimeters of a woman can be approximated by the linear equation that, right, where x is the length of her radius bone in centimeters. So they use the arm to, radius bone is, see, it looks like that's called radius bone. I don't know, what do you call them, the medical people would know. I ain't got no clue. I guess the radius bone is that bone in your arm over there. Okay, so X is the length of her radius bone in centimeter. Y is the height of the woman, okay? And the equation is given there. It says use the equation to approximate the heights of women with radius bone of length 20 centimeter, 22 centimeter, and 26 centimeter. And they say write the information from part A as three ordered pairs. Grab the equation for, yeah, you see the same thing we did before. It's similar to the problem we just finished. So, you are given that equation there. They say find the value of y. This is A. Find the value of y when x is equals to 20, when x is equals to 22, and when x is equals to 26. That's what that is saying. So y is equals to 3.9 times 20, okay, plus 73.5, okay? That's what that one is saying. So we'll work that out. This one here is saying y is equals to what? It's equals to 3.9 times 22 plus 1. What is that there? Is that 73 or 173? Plus 73. 73.5. Okay, 73.5. And then here y is equals to 3.9 times 26x 73.5. Okay, so if we do all this, what do we get? We do all that, so you gotta do one by one. You get all that done. What do you get? I don't want to be out of my range here. You get 3.9 times 22, okay? You get 85 plus 73.5. You get 159. 159.3, okay? So you can do that. It's not hard, it's just what is this? This is number 11. It's just a bunch of solving problems, man. That's all. I'm sorry. It's not sorry. I don't know where I get point. It can be 0.3. It has to be 0.5. Wait a minute. Or maybe it's 0.6. Hang on, let me do it again. 3.9, yeah? Did I do it at 3.9 times 20 plus 173.5? Yeah, I don't know why I'm getting two different numbers every time I do it. It's actually, what is this? It's actually, just give me a minute. I think I'm messing up, man. Okay, when you do that, what you get is 151. 151, the first one, 151.5, okay? The second one is 159.3, the third one is 174.9. And then the problem wants you to, what is that? You write the information from part A as three other pairs. So basically what they're saying what they're saying there is because x is 20, okay, 151.5, the first order pair, the second order pair, 22, x is 22, sorry, and y is 159.3, okay, and the third order pair is x is 26, and y is 174.9, okay. That's all that is saying, man. That's all that is saying, you see. You do it like that, okay. I bet you they're gonna tell us to you grab the equation for x for length greater than 20 using the data. Okay, greater than 20. See, that's greater or equal to 20. Sorry, we're going to talk about inequality. I don't know why I'm dropping off, this, greater or equal to means the 20 is included. So they want us to basically use those three, okay, to draw a graph. That's all they're asking us to do. And then after we draw the graph, use the graph to estimate the length of a radius bone in a woman who is 160. See, it's like the other one we did. We draw a graph. Let me see what, these are not, well, y is almost 180. So we're going to have the same problem here. Okay, just let me draw it and then I'll come back and show you. That way we don't waste too much time. Okay, so what I did, I put the points on the line so you can watch me draw it. You see, I put all the points I needed. So the first one is 20 and 151. 20 is here, 151 is I put it somewhere here. This is approximation, okay? And then 20 is here. So it's right here. The first point is here because 20 is here, okay? So the first point is here. And then 22 and 159. 159.3 is here. You go, I put it there. You come down. This is 22. Go there. So it should be somewhere there. Approximation, And then 26 and 174. 174.9 is right somewhere there. What is that? 26 is here. I draw these lines that way I know where they cross. It helps me instead of trying to figure out. Okay, so I will draw it there. This is approximation, I'm using hand to draw this. And then you put a ruler through them. Through those 3 points, and then you draw the graph like that, through them like that. I guess I did a good job this time. And then so what you do, once you draw that, then you can use the diagram to estimate, man. Because you see, X is the length of the arm, right? And Y is the height of the person, of the woman, okay? So what did I ask you to do? Use the graph to estimate the length of the radius bone in a woman who is 167 centimeter. Where is 167 centimeter? Okay. So each unit here is 5. Between here and here is 5, okay? That's what I'm saying. So what is that? What they say? 167. Okay, this is 150 here. Hang on, let me find it. I'll find it for. Okay, I was able to find it. Here is 167 right there. It's about there. 167. So a woman is who's 167 centimeter tall. So basically what you do when you do estimate, you just go draw a straight line, see where it meets the graph right there. Hopefully we're correct. And then you go down to x-axis, okay? See where it touches x-axis right there. Okay? So notice it's between 22 and 26. Okay, each point on this side, this is 2, 2, 2. So since it's over here, since 22 is here, and another 2 is 24. That's 24. So a woman with so to answer D, okay, we did the graph. Graph is C, okay. B is that. B is the other pair. Graph is C. D is if you're giving a woman who is 167 centimeter in height, then the length of the bone will be 24 centimeter. That's what I got. That's what we got, man. So that's what we got. So hopefully we're correct. If you have a program to draw the graph, it will give you an exact figure, or you can solve the problem using algebra. Okay, so let's move on to the next one. Let's not hang on to that. I think we're tired of these graphs, man. They're giving us graph again. But that what I did, I escaped two problems. That way we're two problems. The next two problems are the same graph we've been doing. So I think we'll get hang of it now. Let's do some other more interesting stuff. Here is the problem here. It said the graph shows the value of a sport utility vehicle SUV over the first 5 years of ownership. You know, when you own a car with number of years, it depreciates in value. Okay, that's what they're talking about. The value of the sports utility vehicle, the value of a SUV over the next 5 years. Okay, and then I think this has to do with, I don't know, we'll see. It looks like demand curve, or what I call demand and supply curve. I don't know. But anyway, use the graph to do the following. Determine the initial value of the SUV. Find the depreciation loss in value from the original value after 3 years, the first 3 years. What is the annual or yearly depreciation in each of the first 5 years? What does the ordered pair 5,000 mean in the context of this problem? Okay, so you see, something like this should be familiar to you now. They give you graph. You are given a graph. Let me change to red pen. You are given a graph. See, there's a point here. This is x-axis. This is y-axis. Okay, they say the x-axis is number of years, and the y-axis the value in dollar of the SUV. Okay. So notice they give you point from here to here, here to here. So see, that's why we took our time and draw that graph, because whenever you see a problem that it should be easy for you, you shouldn't be freaking out. You know, we took our time and show you how to do all that graph. That's why we did that, you see, because graph is important. You see it in a lot of situations. Okay, so the first question is determine the initial value of the SUV. Okay, so you can use the graph to determine it. Let's say the initial value of the SUV. See, x-axis represent years, right? Years of ownership. Right here, 0. X is equals to 0. That's 0 year. So the value is 30,000. So that one is easy. So if you from 0 you go up, it's 30,000. Okay. So the initial value is 30,000. There's nothing there. But do not overthink it. Just use the graph. That's why the graph is important. Okay, so that's how you do that one. Alright, so we'll move on to B. Find the depreciation loss in value from the original value after 3 years. You see why the linear graphs are very, very important, man. You can use by the way, this is linear equation. I told you this is x and this is y. It's linear equation in two variables. Okay, two variables. We've been talking about that forever. Okay, so they're very, very important. Linear equations in one variable, linear equations in two variables, even in 3 variables, 4 variables, 6, but we can only do 1 and 2. When we get to linear algebra, we can do many variables. Okay, so you see why this kind of equations are important. You can use them to model all kinds of situations. Okay, B says find the depreciation loss in value from the original value after 3 years. So you look at the graph again. This is years over here. This line here represents years. Okay, x axis. So look at 3 years right here. 3 years you go up to the graph, and then you go like that. You see, they put that value there. That's 15. So the depreciation loss in value from the original after first 3 years, you see it right there, is 15,000. Okay, 15,000. After 3 years, that's the depreciation value there. So right there, they put there in the graph for you. So don't overthink the problem. Just if you understand the graph, just use it to solve the problem. Okay. And then it says, see, what is the annual or yearly depreciation in each of the first 5 years. What is the annual or yearly? In other words, each year, what is the depreciation each year? That can be determined. That's not that difficult. Okay? So what you do, go see 0. There's no depreciation. It's 30,000, the original value. And look at this here. After 1 year, what is the depreciation right here? The graph is not exact. Well, actually, it's exact. Because you need to know. See, that's why the units are important. What do you think is the unit of the graph? Let's make sure we understand that. They draw these lines here. Let me see. You see the lines, right? I think they faded away a little bit. And then we went through the points in the... You see the lines there, right? And then you see the lines going down to x-axis, okay? You see that there? See, that's 4. This probably, I don't know what the hell is that. This is 3. This is first year. Okay. Now check this out. It says, what is the annual yearly depreciation in each of the 5 years? You gotta pay attention. Each of the 5 years, they give you 1, 2, 3, 4, 5. And notice what is going on. And notice that the graph drops. It's a negative slope. It means something is dropping. Okay. From the 0 year to 1 year, it dropped. But if we know the value, let me see. 1, 2, 3. Okay, well, yeah, 1, 2, 3. 1, 2, 3. So there's a space of 6 on that axis. So 1, 2, let me see, 1, 2, 3. It dropped almost half of its value. You see that? I would say after 3 years, because from here to here is 3 years. So from here to here, for the first year, it dropped. Look over here. Okay, so 1, 2, 3. What do you think that is? I think it's 5,000 that it drops. Because this is over here is 15,000, 10,000. That's 20,000. Over here, let me see. Over here is okay. This is 50. Okay, let's start from beginning. This is 30,000. Over here is probably 25,000. You see that? Okay, and then over here after, let me see, well, let's keep going. 25,000, subtract another 5,000, you get 20,000, okay? That's over here. And then you subtract another 5,000, right? That's 15,000. Then you get this 15,000. So it's dropping 5,000 every year. You see that, right? That's what that is saying, man. So I bet you here is probably, it drops another, over here is 10,000. It drops another 5. Over here is 5,000. Okay? It drops another 5. And then over here is 0. It drops the remaining 5,000. So each year, so if you look at the graph carefully, you see, you can say each year of the 5 years, right? It drops in value, $5,000. That's all that is saying. Okay. What does the other pay? 5,000 mean? I know what that means. If you go here, let me see. Yeah, see right here and right there. That's where the 5,000 is. You see 5 years right here. So it means that's D. Other pay 5,000. Okay. That means at year 5. At year 5, that's what, because because that is year. These are, you see, 5 is year. At year 5, the value of the car, the value of the SUV, okay, the value of the SUV will be 5,000. That's all that means. It will be 5K. That's 5,000, okay? That's all that is saying, man. You know, it's not saying more than that, because you see right here 5, you go up here, where does it cross? It crosses right there at 5,000. That's the value of the car. Because this thing is the value of the car, that the y-axis, okay? All right, we're done with that problem. Just do not overthink it. Just use the graph to determine what they ask you to determine. Let's look at another problem. Let's look at this one. This one says demand for an item is often closely related to its price, which is true. This is economics. And then it says price increases. As price increases, demand decreases. As price decreases, demand increases. Suppose demand for a video game is 2,000 units when the price is $40, right? And the demand is 2,500 units when the price is 30. He said, let X be the price and Y be the demand. See? X price right here, X axis price, Y axis demand. Okay, for the game graph the two given pairs of price and demand on the given graph. Okay, let's do A. Okay, so you given 40. If the price is 40, demand is 2,000. So 40 and 2,000 right here. Okay. If demand is $30, the price is $30, the unit is 2,500. $30 is 2,500. Let me see. $30 is 25 here. Okay. And it's telling you to grab the two given pairs of prices and demand. So if you graph it, it has to go through here like that. It will go like that. Okay, keep going down. It's a downward sloping curve. A linear downward sloping line. Okay, so that's A. We'll grab that. It's a B. Assume that the relationship is linear. Of course, it's linear. Draw a line through the 2 points from part A. Draw a line through the 2 points. Okay, I did. From the graph, estimate the demand if the price drops to 120. So if the price drops to $20. If the price drops to $20, what is the demand? Let me see. Go up here. Somewhere there. If the price drops to $20, right, the demand is 300 right there. You see, that's how you estimate that. So if the price is 20, okay, oh, sorry, that's, I'm sorry. Let's see, that's A. We're doing B. A is the graph, okay? We did that graph. B is estimate if the price drops to 20, then the units will be, what is that? We got 300. Okay, 300 units, okay? That's what they're asking for B. He said use the graph to estimate the price. Okay, if the demand is 3,500, that's C. Okay, what is 3,500 is right here. Because you remember this is 500, 1,000, it increases by 500. That's 1,500, 2,000, 2,500, 3,000, 3,500 is there, okay? So if demand is 3,500 units, it's right here, then you go to the graph right here. Okay, let me see. Actually, it's right here, right here. You know, see the graph is not clear, so you gotta be right here. It's $10. So if let me see. If let's see if there is if the demand is 3,500 units, Okay, then the price is what? It's $10. That's what we got there. So that's number C. Okay. So we do number D. What is that? What does it say? Write the price and demand from part B, C as ordered per. Okay, D from BC. BC is 20. Price goes first because price is in the x-axis, and then 300 units, and then 3,500 units, like that. That's what they want. So that's what we just did. Okay. I think that's what they want. I think we're done with that problem. So, see, demand and supply, they're very, very important. You see, that tells you the importance of linear equations, both in one variable and two variable. So knowing how to solve linear equations in two variable, you understand demand and supply. That's what they're telling you. You don't understand the whole concept, but it helps you to understand it. You see, I know that economists, they use a bunch of graphs. They try to make it so complicated. Sometimes they start drawing curves. Because I had to take microeconomics and macroeconomics. I even took, what is the other one after that? I took intermediate micro and intermediate macro when I was in college, see. So I don't remember anything from there anymore. I thought the thing was dry after demand and supply chapter. After you deal with demand and supply, shortage and surplus, after that the rest of the stuff was just dry for me, too dry. It doesn't. Sometimes they do not make sense. But anyway, don't worry about it. I'm not criticizing an economist. I'm not an economist. I'm just telling you the way I felt when I finished the class. Let's move on to number 14. Let's read that. It says U.S. per capita consumption of cheese in pounds from 2000 through 2016 is showing in the graph and modeled by the linear equation y equals to 0.356x plus 29.7, where x, what is this? Where x minus 0 represents 2000, x minus 2 represents 2002, and so on. Okay. I don't know why they wrote it like that. X minus 0. X minus 2. Okay. Alright. Okay, so no problem. So you say use the equation to approximate cheese consumption to the nearest tenth in 2000, 2008, 2016. Use the graph to estimate cheese consumption for the same years. How do the approximation using the equation compare with the estimates from the graph? The USDA projects that per capita consumption of cheese in 2022 will be 36.8 pounds. Use the equation to approximate per capita cheese consumption to the nearest 10 in 2022. How does the approximation using the equation compare to the USDA projection? Okay. So we know what they're saying. So let's this one cannot throw me off. This thing here minus all that stuff. But again, you see what linear equation can do in two variable. X is over here, y is over here. Y is consumption, x is year, okay? Alright. So use the equation A. Use the equation to determine, to approximate cheese consumption to the nearest 10 in 2000, 2008, and 2016. Okay, so they give us y equals to 0.356x, alright, plus 29.7, okay? That's the equation. Okay, so for 2000, alright. Okay, I think I know what they're saying there. Let me see. For 2000x For 2000, okay, that's 2000 there. This is year, so this is actually 2016. I don't know if you can see that. This is 2016 right there. So the number said 2000, that's what it represents, 2014, 2014, then 2012, 2010, 2008, 2006, 2004, 2002, then 2000 here. Okay, x equals to 0 represent 2000, x equals to 2 represent. Okay, and that one I think this is x equals to 0. Kind of threw me off. X equals to 2 represent 2002, and so on. That's what that thing is trying to say. Alright, so A for 2000, okay. So x is, they're saying x is equals to 0. That's what they're saying up there. For 2002, x is equals to 2. 2002, what is that? What are we looking for? 2008. 2008, then x equals to 8. 2016, so that means x equals to 16. That's what they're saying, and that's how they wrote it here. See, so but anyway, so you put x equals to 0 in that equation, then you get y equals to 0 plus 29.7. That's what you get there, 29.7. Okay, and then you put x equals to 8, you get 0. I'm sorry, you get y. If you do that, you get y is equals to 0.356 times 8 plus 29.7. That's what that is saying. It took me a while to see what they're saying. And then for this one, is y equals to 0.356 times 16 plus 29.7. Okay, that's what that thing is saying. Okay, so you multiply that out and you get, you multiply each of them out, you get of course we got that one, you get 0.356 times 8. Okay, and then you add the 29.7, you get that. This gives you, it gives you 32 point, I think it's 55, because it's one decimal place. So we might have to use one decimal place, 32 point, we'll leave it 32 point, I don't know, man. Is that 32.6? If we approximate it, that's what it will be. 32.6, right? Because it gives us in one decimal place. Okay, and then this one will give us what? Let's find that out. 0.356 times 16 plus 29.7. You get, okay, right here you get 35 point, I think that's the 0.4. Okay, that's what you get there. You get 35.4. Okay, all right, you see that, right? Use the graph to estimate cheese consumption for the same years. Okay, B, that's what B is saying. B saying use the graph to estimate for the same years. You estimate, what is Y? Y is beef consumption, right? Okay, so we calculated it. They say use the graph to estimate it for the same years. Remember, the first year 2000, then 2008, then 2016. If we use the graph, 2000 is right here. See, 2000 lies on the graph right there. For 2000, it will be 30. Consumption will be 30. Okay. Yeah, that's the estimate. For 2000, let me see, what was that? 2008 is right here. If you estimate that right there, you go up, it will be right there. So where does it go? Let me see. I know this is 32, so right over here. So it will be somewhere here. So the unit is 4. 30, 32, 34 is 4. So that thing is probably a load of, I would say about close to 2. It's close to 34 or maybe 33 something. Okay. So 2008, I would say close to 33, okay? Alright. And then, what is the other one? 2016. 2016 is here. You approximate it, go to the graph, see where it lies right there. And then you gotta go back this way. It looks like it's 36. You know, it looks like it lands at 36. You know, we're not always precise. So 2016 is at 36. Okay, so that's the best I can do. I don't know if I did it right. That's the best I can do, you know, given that the graph is not, you know, the graph is really not, I don't know, man. So that's the best I can do there. That's, what is that? That's B, right? That's the best I can do there. And then what is C? How do the approximation using the equation compare with the estimate from the graph? How the approximation using equation? They will close. Because you see right here, they cannot close, man. You know, they cannot close. See? It's almost started there. So, what is this? This is C. The approximation, right? We are close, right? I would say we are close. We are close to the estimates. Basically close. Okay, approximation using equation, close to estimates. Okay, using graph. Okay, what is D? D, the USD project that per capita consumption of cheese in 2022 will be 36.8. Use the equation to approximate per capita cheese consumption to the nearest tenth in 20. How does the, okay, they want to use the equation there. That's D. Let's do D here. They want us to use the equation. We know the equation. Yeah, let's do D there. We might have to take, we're gonna have to take more. I don't want to go over. We're gonna have to, sorry. We're gonna have to go like this. Take off all the space here to do D. Okay. So the equation is y equals to 0. What is that? 0.356x plus 29.7. So for the year 2022, based on the way they're doing this thing, we will say x equals to 22. You see, you understand? X equals to 22. Then that will give us y is equals to, alright, 0.356 times 22 plus 29.7. Okay, that's all. Because that's how they, you know, they're using the years. They use the last 2 digits, right? Okay. Yeah, 0.356 times 22 plus 29.7 is equals to, this is equals to 37.5 Yeah, 0.5. We'll leave it there. There are some figures, but they're lower numbers. Some digits are after 5. Let's see what it do. See, this is what we got from approximation, and then it asks how does the approximation using the equation compared to the USDA. USDA is right here. USDA is 36.8, and we got 37. So theirs is higher. So almost 2 points. Because ours is almost 38. They got 36. No, ours is a higher. Ours is a little higher. The equation, you see, the approximation using the equation is a little higher. Than the figure quoted by FD. What is that? FD. I mean USDA. Sorry. By USDA. See US. Okay, so that's what we can say there. There's nothing else more to say. See, so. Because you see, let's subtract it. If you subtract it, what do you get? The USDA said 36.8. Ours said 37. So ours is a little more, right? Let's say 37.5 minus 36.8, right? Let me see. If you subtract that, what do you get? You get, all right. It's 37.5 minus 36.8. It's about 7. The difference is about 7. What they call that? 7. I think it's 7 pounds, right? I mean 0.7 pounds. That's the difference. But we're done with that, man. We'll leave that alone. We'll go to the next one. Let's go to the next one. This may be the last one. I don't know what else I have for this video. I think we'll leave it here after this one. I'm tired anyway. So let's say the number of US marathon finishers. Why? In thousand from 20,000 through 2016 as shown in the graph and modeled by the linear equation right there. Y equals to 12.68x plus 340.9. Where x equals to 0 represent 20,000, x equals to 4 represent 204. See, they're doing the same thing. So this x is years, the number of finishers is y, and they're using years as numbers. Okay, that's the same thing we saw before. Then he say use the equation to approximate the number of US marathon finishers to the nearest 1,000. Okay, see the same thing we did before. Just a little different words. Okay, different equations too. So it's okay, man. Let's do it. Say well, practicing. So the equation given us is they want us to approximate x equals to 4. X equals to 12, x equals to 16, given this equation, y equals to, what is that in there, y equals to, it's at 12.6, let me see, 12.68x, is that plus, 12.68x plus 340.9, 340.9, okay, for when x equals to 1, then y is equals to 12.68 times 4 plus 340 340.9. Let me make sure I copied it right. 12.6 340.9. Okay, so that's what that one would be. So this one, y equals to 12.68 times what is that, 12 plus 340.9. What would that be? This one, the same thing, y equals to 12.68 times 16 plus 340.9 is equals to that. All right. So that's what they want you to do there in A. All right, so we'll smoke that out. 12.68, all right, times 4, and then you add plus 340.9, right? So that one you get 391.62. How many days is it to the nearest what is that again? To the nearest 1,000. Okay, it's okay. Okay, we'll leave it 62. Alright. And then 12.668 times 12 plus 34.9 is equals to 493.06, okay? And then 12.68 times 16, okay, plus 34.9, and I'm trying to give you 543.78. You see that? That's all we got there. We got those things there. Okay, so that's what we got from by using calculation. Right, that's what we got. So we got that. Right? Anyway, so that's A. So B, you say use the graph to estimate the number for U.S. marathon finisher for the same years. Okay, we got 2004, 2012, 2016. So 2004, 2012, 2016. Okay, if we estimate that from the graph, 2004 is right here. We'll go up. Okay, so between, I don't know, man. If you estimate that, it will land here. It's the difference is 100. So it's above more than half. So it's actually 350 something, maybe 360, I would say. It's a little bit high. Let me see. 300, because it's more than half, 350, so a little above 3. So I know it's above, it's more than half. So it will be about 3, let's say 380. And then this one here, 2012, so here you go up here. And it's almost close. It's actually close to 500, okay? So we'll say, let's say 490, okay, or even 492 or something, I don't know. Yeah, this is not very precise. Then what is the other year? 2016. You go from here to there. It's a little bit over 500 right there. Quite a little bit over 500. A little bit over. So let's say 500. Let me see. Yeah, it's quite a little bit, maybe 515, something like that. But that's my estimate there. Use the graph to 7 years. How did I present it using the equation compile? Yeah, see, they are close, but they're not quite close, because you see, you got 390 something. Maybe I made a mistake here. It could have been 390. Maybe I didn't read the graph right. This could have been 390 something. Okay, so I changed my answer there to get close to their safe, kind of cheating. I think they're close. Their approximations are close, man. That's all I can say. They kind of close. They're not too far. They are close. They're actually not too far, see. They're kind of close. I mean, I don't know how else to read that thing. I would say they are close. Let's say the approximations, the approximations are close. That's all we can say. Are close. Close to the estimate, okay, from the graph. The graph, we estimated it. That's all we can say, because if you look at them, 490, they're not too far. 515, they're not too. Wait a minute, that one is too much. Yeah, that one is off, man. 515. Let me see. What did I do? 2016. Let's see here. You go up here. It's a little bit over. It's a little bit over, almost on top of the graph. So I don't know where how that one is for 543. That one is off, man. This one is off. But anyway, that's the best I can do. Some of this stuff you really have to use a computer to generate a better graph. So please, let's leave it there. Thanks for coming. Subscribe to my channel, like and share this video. If you have any question, leave it under the video. I will get to them. Okay, please, thanks. I'll see you in the next video.